Hey students, today we're going to cover section 7.3, which is actually two parts, part 1 area of kites and part 2 area of trapezoids. So if you need to only watch the part about the trapezoids, just go ahead and fast forward the video a little bit to watch that part. If you need to watch both, then you're just going to start here. So we're going to start with part 1, area of kites, and the learning target is I can find the area of kites using decomposition. So what is a kite? Because you may have heard of like a kite you fly in the sky, but not a mathematical or geometrical shape. A kite is a quadrilateral, so a four-sided figure that has two pairs of adjacent sides with the same length and opposite sides with different lengths. So adjacent sides are sides that touch. So if you look at this kite here, it looks like what you'd probably imagine a kite in the sky to look like. It has two sets of sides, adjacent sides, so the ones that touch that are equal in length. These two are equal, these two are equal. And the ones across from each other or opposite from one another are not. So this side and this side are not, this side and this side are not. So that's what a kite looks like. And the way we're going to find the area of this kite is by actually using decomposition. That's what we used when we found area of composite figures in our last section. So we're going to imagine taking some scissors and cutting apart the kite into multiple shapes that we can find the area of, and then gluing that back together by adding our areas together. This kite, if you look at it, looks like a bunch of triangles, and I can actually split it. I could split it into 4 if I wanted to, but to make it even easier, I'm just going to split it into 2. Now I could split it right here, and I could have this triangle here on the left and this on the right. However, if I split it horizontally, this triangle on top is the exact same triangle as the one on the bottom. And that's going to be easier for me because that means I only need to find its area once, and I automatically know what the area of the other triangle is going to be. So for the purposes of this kite, I'm going to go ahead and split it right there, and I'm going to draw a line to kind of help show that. And if we want, we can now even go ahead and imagine drawing this triangle off to the side without that bottom part there. So it would look something like this. That's not perfect, but it's close. And I'm going to go ahead and add in those labels. So it looks like I had a line going straight through here that was 4 feet. And now down here, it shows that from this point there out to the end is 6 feet, and that this point here into that spot is 3 feet. That means the total of this entire side of my triangle is going to be 9 feet long, because 6 plus 3, because there's 3 there and 6 there. Now I'm going to go ahead and find the area of this triangle that I've just drawn. So the area of a triangle is base times height divided by 2. The base is going to be this 9-foot side, and my height is this 4-foot side. Remember, a right angle is always right because it shows the base and height. So 9 times 4 divided by 2. 9 times 4 is 36. Divided by 2 is 18 feet squared. And we may be really tempted to just be like, oh, I'm done. But remember, that was actually only half of the kite. It was only the triangle that forms the top of the kite. I now need to find the area of the triangle on the bottom. However, remember, we split it this way intentionally because this one's area is going to be exactly the same. That means I automatically know I'm just going to take my 18 feet from the top triangle and add it to 18 from the bottom one. So total, my area of my kite is 36 feet squared. If you split it vertically, you would just have to find the area of 2 different triangles. You can totally still do that. It's just more work. We're going to try another one. So again, I'm going to split my kite into 2 triangles. This time I am going to split it vertically because imagine folding this over onto itself. The left and the right sides would be the same triangle. Splitting it horizontally, I would get one larger triangle and one smaller one. So it's easier if we split it this way and make 2 equal ones. And just like last time, if you want, you can go ahead and draw one of those triangles by itself if you need to. So here's mine. I'm going to add those labels. So I had a measurement going through here. That was 3 miles. And then just like last time, I'm given 2 separate measurements along this side of the triangle. From here to the top, it's 7.5 miles. From here to the bottom, it's 2 miles. So I have 7.5 and 2. But all together, if I add that up, that would be 9.5 miles. So now I'm going to go ahead and find the area of that triangle, which is base times height divided by 2. Our base is 9.5 and our height is 3 because a right angle is always right because it shows the base and height. Those two sides forming the right angle show my base and height. Again, this full 9.5 mile length, not just one of the individual parts, but the whole thing. So I'm going to do 9.5 times 3 divided by 2. 9.5 times 3 is 28.5. Divided by 2 is 14.25 miles squared. Again, I know some of us are going to be really tempted to be like, I'm done. But this was just one triangle, one half of the kite. I now need to find the area of the other half. Thankfully for us, we split it in a way that this area is the same as the one we just found. So I can just go ahead and double that or add it together 2 times. And I get 28.5 miles squared. That's the full area of the kite. So to find the area of a kite, quick recap, split your kite into 2 preferably identical triangles, find the area of one, and then just go ahead and double that area. But you theoretically can split it to have 2 separate triangles that are have different areas. It just means you have to find 2 areas separately, but you can do that. Moving on to part 2. This is about finding the area of a trapezoid. So a trapezoid is a quadrilateral where we have one set of parallel sides and one set that is not parallel. So something that looks like this. The top and bottom are parallel, the left and right are not. Now the area of a trapezoid has the most complicated formula so far, and that is 1/2 the product of its height and the sum of its bases. So we can look at it like this: 1/2 times height times the bases added together. The way that I like to think about this is because there are 2 bases or 2 flat sides, 2 parallel sides, I have to take their average before multiplying it by the height. And taking their average means to add them and divide by 2. So 1/2 of the bases added together. That's how I remember it. I prefer to write the area formula in this way: height times base 1 plus base 2, all divided by 2. So similar to the triangle formula where you can think about it as either multiplying by 1/2 or dividing by 2. So we're going to go ahead and try it out. So we have a trapezoid here because these sides are parallel. These ones are not. They would eventually run into each other. And that means I need to use this formula: height times base 1 plus base 2, all divided by 2. Now remember, in a trapezoid, there are 2 bases, base 1 and 2, and those are the 2 things I'm going to add together. And those are the 2 parallel sides, so 9 feet and 5 feet. It doesn't matter which is base 1 and which is base 2 because in addition, the order does not matter. And then the height is always that line that's going straight between the 2, which is 6 feet. Remember, a right angle is always right because it shows the base and height, but there's also a right angle here, which is why this is an additional base. I know some people are probably thinking, but in a rectangle, there's a side up here that's also could form a right angle with our height. Yes, however, in a rectangle, these 2 sides are equal to each other. In a trapezoid, they are not. So that's why we have to use both. So we're going to go ahead and replace our, substitute our height and bases with these particular values. So height is 6 times base 1 plus base 2, 9 plus 5, divided by 2. I'm going to do the grouping symbols first. 9 plus 5 is 14. Then I'm going to do 6 times 14, which is 84. And then divide that by 2. I get 42 feet squared. That's the area of our trapezoid. So again, the way I kind of thought about it was adding my bases together, and that divided by 2 is because I need to find the average of the 2, multiplying by that height. We're going to do another one, again, a trapezoid because the top and bottom are parallel, but these are not. Trapezoids can also be drawn like this, where the left and right are parallel and the top and bottom are not. It does not matter. And I'm going to go ahead and write down my formula. Area equals height times base 1 plus base 2, all divided by 2. Remember, the bases are the parallel sides, so in this case, that's the 11.5 and the 8.5, and the height is the line going straight between them, the 5 meters. A right angle is always right because it shows the base and height, and then across from the base, I have my other one. So I'm going to plug in or substitute those values. Height is 5 times base 1, 11.5, plus base 2, 8.5, all divided by 2. 11.5 plus 8.5 is 20, because I do my grouping symbols first. 5 times 20 is 100, and 100 divided by 2 is 50. So 50 meters squared is the area of this trapezoid. Now I have one last one. It says find the area of the figure. This is a composite figure, meaning it's made up of multiple figures. So I'm going to go ahead and take those imaginary scissors to split it apart, find the individual areas, and then glue it back together by adding the areas together. I'm personally going to go ahead and cut it right here so that I can form a rectangle on the top and then a trapezoid on the bottom. The area of the rectangle is just base times height, so 6 times 4, which is 24. And then the area of the trapezoid, I'm going to use the new formula we learned, height times base 1 plus base 2 divided by 2. Remember, the bases are the parallel sides, so 8 inches, and then this side, which is not labeled, but we can see its label up here, 4 inches. So those are my bases. And then the height goes straight between them. So that would be this measurement right here from this top base to the bottom base. That is not labeled. However, I do know from the very top to the very bottom is 8 inches. And the rectangle takes up 6 of those inches, meaning this is going to take up 2, the last 2. And that's my height. So height 2 times base 1 plus base 2, 8 plus 4 divided by 2. Do my grouping symbols first. 8 plus 4 is 12. Then I do 2 times 12, I get 24. Divided by 2 is 12. But don't forget, this was just the area of that trapezoid right there. We also had that rectangle on the top, so now I need to add those together. 24 plus 12 to get the total area of 36 inches squared.